We have Aaron Stannard, how do you say that? Stannard. Aaron Stannard talking about the future of distributed programming using .NET, Akka.NET.
This button?
Yeah.
I got it.
Not that button.
That button. All right. Just get that working. Good. All right. Hello, everybody. Today, we're going to talk about the future of distributed programming in .NET with Akka.NET. My name is Aaron Stannard. I'm the co-founder of the Akka.NET open source project, and I'm also the CTO and co-founder of PetaBridge, a company that is dedicated to providing commercial support, tools, and training for Akka.NET. This talk is 30 minutes long, so the expectation I want to set with you is we're not going to be diving into a lot of code, demos, or examples. Rather, what we're going to talk about today is the why this is important to us as a developer community and what possibilities it can create for each of you individually in this audience as developers. I firmly believe that .NET has an important and vital role in the future of software, that the CLR and Mono are both evolving in directions that are going to make the platform even more impactful and influential than it already is. And there's a big new future that this presents for us. And I invite you all today to imagine yourselves in a possibility where you are playing a pivotal role in every step along the way. And we're going to talk about that by taking a brief trip back in time into my own past and talk about what I was doing before PetaBridge. This is my previous startup, MarkedUp Analytics. We were an app and device analytics company dedicated to serving Windows Store, Windows Phone, and eventually even Win32 desktop applications. We would record metrics from an SDK instrumented inside their application to a central service that we managed on Amazon, and we would be able to provide real-time updates as to how many people installed the app, how many people had bought something, what sorts of things people were doing, and what sorts of things people weren't doing too. It was a great product that was really successful. So here are some numbers to quantify just how big our little product was. 30 million. That's the number of distinct devices per month that connected to our services. 500. That's the number of megabytes per second of event data that had to go through our app and into our database, as measured by our load balancer. Thankfully, it compressed a lot better than that when we saved it. But that's what we were dealing with in terms of our load. 100 million. That's the number of database transactions committed successfully per day. It's a lot. It's a big scale. And it's even more impressive when you see the next number, 30. That is the total number of servers we had running all of this workload in production every day at any given time. We used auto-scaling so that number could be a little bigger, a little smaller, but that's the average. That includes our database servers, our application servers for each service we ran, and also the little auxiliary stuff for doing one-off tasks and everything else. So we had a really successful product. Over 1,000 app developers were using us, including Cut the Rope, Stumble Upon, you name it. But on the other half of the coin here, the metrics weren't so pretty. We had a struggling business. This product was a loser, did not generate any money for us, and we couldn't charge for it. We had 12 months of runway. For those of you who don't know what that means, that's the amount of time you have before you go bankrupt when you're a business. 3, that is the number of engineers we had on our team, including me. 3, incidentally, is also the number of total employees we had. So I was responsible not only for development and architecture, but also managing 2 other engineers, doing all of our sales, working with our investors, our lawyers and accountants, you name it. It was a stressful job. And then finally, the scariest number of all, 0. That is the number of engineers with prior distributed systems experience before working at MarkedUp. So I'm going to show you some things in this slide that are personally embarrassing for me in the next couple of slides. But here's my hope. A lot of us limit ourselves in terms of what we think we're personally and individually capable of achieving as developers and what our platform is capable of doing. I'm going to show you how I worked through that and created a new possibility for myself, for my team, and every other person I've trained on Akka.NET since. So we came up with a radical new product idea. Our fundamental business problem was that analytics and reporting for your apps was commoditized by services like Google Analytics and Flurry. Even though we had an ostensibly better reporting product, it wasn't enough to generate revenue. So we came up with a radical idea, and this is the original architecture diagram I used to propose this to my team. We decided to allow our customers to use that same event data we were capturing for reporting and analytics purposes to react and send messages back to the users in order to start conversations and sales opportunities. So they'd integrate our SDKs into their application, deploy their app on the Windows Store or whatever distribution channel that platform used, and we would instrument it and collect lots of events about what users were doing and what some other like demographic properties of the user, like what country they were from and so forth. Our customers on our service could go and create a campaign. We want to target users who have behaviors X, Y, and Z, and then send them a message designed to achieve some goal. Maybe it's getting the user to use the app again. Maybe it's getting them to buy something. Maybe it's getting the user to recommend the app to a friend. The goal didn't really matter to us. All that MarkedUp cared about was making its customers successful. And our customers were people like us, fellow app developers. Who wouldn't want that for their fellow developer? So the final step was being able to go and push data from our cloud back into the apps where our SDK was instrumented. So we wanted to create a bi-directional system for communicating with our users. So to sum up the sort of value proposition for what this product did was we wanted to give our customers the opportunity to start conversations with specific types of users as determined by the user's behavior or lack of it. One really interesting functional requirement came up right away, though, during our initial prototyping and testing. Whoops. Oh, no. There we go. In order for best results, this had to be done in real time. Delivering a message 60 seconds after a user had qualified for a campaign resulted in like a 300% decrease in conversion. So we had data to back up how important this was. So we had to make decisions about which customers were qualified to receive messages in seconds for many campaigns. There are other campaigns our customers wanted to run where this wasn't an issue. But we knew that if a customer needed it, we needed to be able to deliver on this. So, implementation time. I'm ex-Microsoft. Everyone on my team were all career .NET developers. So we went with what we knew. ASP.NET MVC in a database. Now, for those of you who have distributed systems experience, you're going to laugh at the next two slides. So please spare me your judgment. Read after write is the technique I call this. Take a bunch of events, write it into a database, read the result back out where you're still waiting to send a response back to the customer, and then send a message over the wire if you have all of the satisfied events in your data store. So here was our theoretical view of the world, as determined by our current architecture we had for our analytics product. We had a user. This could represent a mobile device. So someone running one of our customers' apps on a phone or a tablet or a desktop. We had a really big HTTP load balancer that handled our analytics workload. This is all running on Amazon. We had a whole bunch of IIS servers running ASP.NET MVC. And so this was all done with really good DevOps stuff for elastic scale and blah, 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 buzzword. And then we had a massive Cassandra cluster sitting underneath all of this, powering our analytics. So about 12 pretty large nodes on Amazon. And so our theory of how this interaction would work with our first prototype was to do what .NET developers have done for a long time. In fact, it's not just .NET, it's web developers in general. Treat the database as the single source of truth. So, we have 4 events total that we need to see from some user in order to qualify them for a campaign. And our SDK time-ordered these events. So, hey, everything should work out, right? So event 0 would come in, write that to the cluster, would go ahead and read what the current view of the system was, and would say, okay, event 0 is in our database, great. And rinse and repeat that for 1, event 2, and so forth. And so finally, when all 4 events are present in the database, we can go and just send a message right back to that user. Everything was good, life was great. So this was our theory and how it worked, and we built a really lightweight prototype to test this. So here's what the reality looked like. The answer was complete and total chaos. We had no idea when the hell anything was actually happening. Event 3 would be written to the database before Event 1. Event 0 would get this totally inconsistent view back that had no data whatsoever, and blah, blah, blah. So our sort of state of the universe was just, complete chaos, in other words. Nothing worked the way it expected. And so me and my team did some brainstorming. We're smart engineers. We've built a massive big data product. We can figure this out, right? So strategy number 1 must be the database's fault. Damn you, Cassandra. Well, we thought about it. If we tried putting SQL Server under that workload, it would be crushed like a beer can by the amount of traffic that we were throwing at our Cassandra cluster. ACID databases are not good at write-heavy workloads. That's just a fundamental principle of the physics involved in all the storage and consistency mechanisms needed to do it. So we were like, all right, we already have the best-in-class database, so that may not be the problem. So what else can we do? Well, how about put a cache in front of it? Have a materialized view of all the data. Well, we figured that was basically the exact same problem, but just double in 2 different places now. All right, well, what if we put a queue in front of the database? That'd sort everything out, right? Order it in the queue? The answer was no, not at all. There'd be nothing to be able to react back to the user at that point. And plus, our problem was on the read side, not the write side of the equation. So, with much humility, I reached the conclusion that I had no idea how to build this product. I was hopelessly and utterly screwed using the tools that I had learned and depended on for so many years to build this thing. So what am I to do? I had no vocabulary to even describe what was wrong with that approach. I couldn't Google my way out of this problem. There's no literature for build event-based marketing automation system in .NET out there. So I couldn't Google my way out of my problem. I couldn't even really describe what I needed to anybody. I was stuck. So I wandered around in my office like Russell Crowe from A Beautiful Mind, mumbling to myself, swearing, not showering, sleeping in the office. I had to be sent home by the people who managed the building at one point because I was sleeping there. Furiously trying to whiteboard my problem and model it over and over and over again. It was some pretty sick shit. But I had a breakthrough, finally. My breakthrough was this. If I took every single piece of my architecture out of the equation, except for the one piece I couldn't get rid of, the connection between the SDK and our network, which is our load balancer, then I found what the real source of the problem was. All of the user's events needed to arrive in the same place. Boom, then we can make it work. And I realized there's a word to describe what this problem is. It's a stateful problem. Yes, I'm inching a little bit closer towards something I can Google now. So, not quite there yet. Stateful is a big word. I needed something more specific. So I went back to Russell Crowe-ing my way through the problem one more time. And I realized that one of my big problems is, HTTP is a stateless protocol. Everything I'm using is wrong. So what am I going to do? Breakthrough number 2 was, I realized if I treated the events coming in from the SDK as a stream of data I had to observe and react to, that it was really a stream processing problem. That's a buzzword. Yes, I can Google that. I had a stateful, reactive stream processing problem. Awesome. And you know what? TypeSafe, the company that makes Akka, SEOs very well for that. So I found an answer to my problem on Google, finally, at long last. Akka and the actor model presented a very elegant solution to my problem. I could go and fire all my events at my web server and write a little server that used sockets sitting behind it, running the actor model, that could make sure all of the events got collected in one actor pertaining to that user and that campaign. And once it was satisfied, it could send a response back. Awesome! That is a perfect solution to my problem. So, only one issue though. Akka is written in Scala on the JVM. And the actor model is pretty weird first time you look at it. It's a totally new concept. But here was my reasoning. 1973 was the year the actor model was invented. That's when Carl Hewitt published the white paper describing how it's supposed to work. That makes it only 3 years younger than the relational database. It's an old concept. In 1986, Joe Armstrong wrote Erlang for AT&T. This is the first production-ready version of the actor model that was really heavily used and battle-tested, and it got open-sourced later. In 2013, December specifically, was when I was doing all this research. So my reasoning was, man, this is actually a pretty old, stable, battle-proven technology. Surely this has been implemented in .NET already, right? Of course not. There was absolutely nothing done in .NET on this. There were a couple of half-assed, abandoned Microsoft research projects that sort of explained some stuff and had some code that was written for .NET 3. And then there were a couple of projects that some hobbyists had taken on that were, while they're pretty full-featured, didn't include any of the actual actor capabilities I wanted, like the networking and distributed parts of it. So that was a problem. So I got really desperate, and I evaluated porting all the parts of our application we needed for this product to the JVM, which meant that I would have to, one, re-architect a big piece of middleware we had invested 3 years of time into in Java in order to make it work. I have to retrain all of my people and redo all of our DevOps processes under that massive workload that we have. So, what's the alternative to doing that? Well, if I'm not going to port my people to use this framework, I can port that framework so my people can use it. That's what I did. I decided to bite the bullet and port Akka to .NET. And as it turned out, there was the person who co-founded Akka.NET with me, Roger Alsing, was also working on this problem simultaneously. So we teamed up and joined forces. And in 6 months, we were able to do the following. I forgot to mention, not only was the actor model never ported to .NET successfully prior to that, a freaking socket server that Akka could use wasn't ported. So I had to write that too. That's where Helios came from, the socket server that powers Akka.remote. We ported Akka.NET, the core and the remoting infrastructure I needed to actually run my business on top of this. And somehow, we actually also managed to ship our app at the same time. So the three of us did all this in 6 months. And it was extremely painful and took an absurdly lot of coffee to do it. I probably put on 30 pounds and just grub-hubbing all the time while I was doing this. But we made it work. But unfortunately, that wasn't enough to save MarkedUp. The technology was successful and worked great, and customers were amazed by it, but we just didn't have enough time on the clock to go and continue to sell it. But that's okay, because what came out of all that effort was a really successful open source project that thousands of people have started to use. And in November, when I shut down MarkedUp, I had tons of users reach out to me directly and say, hey, my company's trying to do this fleet tracking app using Akka.NET. Can you help us figure out? Or my company's doing a multiplayer game on Unity. Can you help us figure out? Or we actually build analytics for the oil and gas industry, and we need a little bit of help working with our sensor array. Can you? I realized there is an opportunity here to really go and take all of the pain that went into building this for MarkedUp and save .NET developers the time and effort to do it, but also allow every .NET developer to be individually way more powerful than they were before. And that's why Andrew and I, the instructor from our Akka.NET course yesterday, started Petabridge together to help make sure that's possible. Akka.NET is a framework that creates totally new possibilities for each and every one of us as developers by giving us new ways to look at problems and a vocabulary to describe issues that frustrated the hell out of me at MarkedUp. We can start thinking about bigger possibilities than what we've done in the past. Because the reality is we live in a much bigger and more demanding world than we did a few years ago. Data is trivially cheap to collect and store. Now you might think, well, that's a great option that I have. Well, that's where you're wrong. It's a business necessity to collect it and use it. So that means you need to develop the tools and the mental muscle to work with large volumes of data. ASP.NET ain't going to cut it. So we have to start thinking about that as a new reality that we are tasked with. The second is that users accept nothing less than excellence. When was the last time you ranted and raved about how great that 3-star app was? You didn't. As far as the user's concerned, it's shit. And finally, customers expect a lot more from developers. Having the best analytics and reporting experience wasn't good enough for MarkedUp's customers, even though we were best in class for that. We had to go beyond that, and that's where MarkedUp Internet Marketing came from. The single-page web application wasn't invented because we felt like it. It was because customers demanded excellence, and that was the abstraction we came up with for delivering that really well on the web. So these are the 3 burdens that we have to carry as developers. And here's what I'm going to propose. Rather than seeing them that way, as sort of things that we have to fight and resist and work around, let's treat them like possibilities and opportunities for us to tackle new problems with new ways of thinking and become more powerful as developers. Let's stop fighting reality. So here are some examples that I've heard. Applications should be stateless. We saw how well that worked for MarkedUp Internet Marketing, right? Trusting the database as the single source of truth was the road to ruin there. Request and response is how networked applications should work. You're basically limiting yourself to HTTP and having to have explicit acknowledgments for everything. In certain types of applications, this is going to stop you from being able to handle that big volume of data or getting that 40 millisecond response time. So request and response can't be the only option anymore. How about ACID? Every DBA's favorite word, right? It must be ACID. MongoDB sucks, blah, blah, blah. The reality is that ACID is only one tool, and it's not the right tool for every problem. Just put a Q in front of it. Let's be honest, this has been a bad idea, even in the old reality, too, for most cases. Really, there's a lot of cases where it's still helpful, but that's not a solution to a scaling problem when you're dealing with writes. And lastly, we're all guilty of this. Microsoft will just do it for me. I'll wait for the next version of ASP.NET or Visual Studio or SQL Server Auto Scaling Edition, whatever, to come out. Ain't gonna cut it. We're gonna have to look for solutions on our own or outside Microsoft. These aren't right or wrong ways of thinking. They just can't be the only way of thinking anymore. We have to expand our toolbox. So those tools were the right way of going about a previous version of the world where data was more expensive, customers were thrilled they could just get anything on the internet or anything in the App Store, and they didn't want all the bells and whistles that we now need to bring in order to win in the marketplace. Here's what new reality might look like. Concurrency is our friend. And when I say concurrency, I don't just mean the TPL and threads. I mean running your apps concurrently across thousands of machines or hundreds of them. Concurrency is a bigger concept than just multi-core processing. It's a way of thinking about your business in general. My application can be the single source of truth. What if you treated your database as just a backup? The state that your application has while it's running is the single source of truth. It's a completely radical idea, isn't it, from where we've been? Particularly if you're coming from the relational database world. This is, heresy there, for all intents and purposes. Eventual consistency. Real life is eventually consistent. When people want to talk about the need for full consistency, they hold up financial applications as the holy grail. Like, how could you possibly have a bank where things weren't immediately consistent? How could you have a stock trading platform where things aren't immediately consistent? And the answer is, they're not, even with SQL Server. Why do you think we have settlements at the end of a trading or banking day? Because even in an environment where you're dealing with relational databases that have full ACID and compliance, you still have to shard that data across many machines. And the speed of real life is faster than software. So there still needs to be a time to make things resolute, even in a system that touts full consistency. Real life is eventually consistent. Let's make that an idea that works for us, rather than something we work against. Reactive programming. I don't need to ask about the state of X, Y, and Z. I don't need a response to be sent back to me right away every time I make a request. I can just react to what I'm told. That really simplifies a lot of the problems, wouldn't it, that we have? Think about all the polling and everything else you have to do in some of your systems today. Where do you can just react? Not worry about whether or not you're going to get a response back right away. It's pretty radical. And location transparency. People who were in the Akka.net training yesterday saw me send a actor that wrapped a SignalR hub to a Windows service that wrote directly to it. How is that possible? Because in the actor model, and the Akka.net exposes, it's transparent to you whether this piece of code is running on your machine or another machine 1,000 miles away. Makes it a lot easier to take advantage of things like cloud computing, doesn't it? And autoscaling. You don't have to explicitly know the address of every machine on your system. Your tools can help you do that for you. And that's a really powerful idea, particularly when you combine it with some of the other things on this list. That's really what Akka.net does. It allows you to pick and choose from these concepts that which are most appropriate for you. You don't have to take what you've been using for years and just dump it into the trash. That's absolutely not what I'm suggesting. Rather, think of this as an addition to what's already in your toolbox. These are new ways you can reason about your code and can reason about your business too. And it gives you the vocabulary to take on bigger and bigger problems. So what will this make possible for you? Have you been limiting yourself by thinking that game programming is just something that's too hard for me? Or big data is something that, those guys in white lab coats who do Java or R all day long are supposed to do? The answer is, as .NET developers, we are perfectly capable of doing all of this ourselves. And maybe for a long time, the culture of our ecosystem has prohibited us from developing the same sorts of tools you can find in Python and the JVM. But the reason why this conference is happening and why you're all in this room right now is because that's changing. You are all powerful as .NET developers, and you can fully exercise that by taking these ideas from the new realities that we have and putting them to work for you, in addition to the tools you've already had. So I'm going to invite you all to create your own possibilities and go to learnakka.net, sign up for our free boot camp, and see if this is something that can solve some problems for you. You might be surprised. And that's it. Thank you very much. Guess we only have time for one question. Yeah. Anyone got a question? Not very good at singing, so this might be a little boring otherwise. Well, I guess we'll just have a little staring contest then. I'll just stare you all. There we go.
What's the elevator pitch for the actor model?
What's the elevator pitch for the actor model was the question. That's a good question. The actor model gives you a really simple unit of concurrency, the actor. Think of the actor model as different from OOP as procedural programming is from OOP. Your fundamental unit of work is an actor. And actors are inherently asynchronous. Every time you send a message to it, that gets dispatched on any thread that's available to you. So all of the work that we have to do for normal shared state concurrent programming, locks, synchronization mechanisms, critical regions, all that stuff, those terms disappear from your vocabulary of the actor model. And so you can do that all on one machine, seamlessly work with all the cores in any individual machine. But imagine being able to do that across a network of machines, cooperatively working together in a way that's transparent to you when you write your code. That's the framework the actor model really exposes, is the ability to just take advantage of all the cores of all of your machines in a way that is simple, elegant, and really small, atomized code. Your code footprint is very small with actors. Now, there's a lot more to it. We spent 7 hours talking about it in our training courses yesterday, so I'm a little hoarse. But that's the elevator pitch. To answer your question? Can you elaborate on the concept of the application that has a single source of truth? I see the hook is starting to come on stage here, so I'll do this really quickly. The idea is stateful application programming. That the state of your application in memory as it runs is the current state of the system. anything you write to the database is just for backup and recovery purposes in the event of a failure. Or maybe going and looking back at it historically later after it's run. That your application's core function is to basically mutate that state in a way that advances your goals. So that's the idea of stateful programming. And so when your application's state is your application, then the state in the application is the single source of truth. It's one of these things where, in order to really understand the power of it, you need to be in an environment where you can really use it. So a good example of something that everyone can try here today, I would play around with building like a really simple multiplayer game where you have more than one person in the game session at any given time. That's a stateful application right there. The state of the game as it's determined by the game server. If you had to round trip back and forth to a database every time someone did something, what would happen? It'd be the worst Counter-Strike match of all time is the answer. So that's a great question. Thank you.
All right. Well, thanks so much, Aaron. All right, we're going to take another about 5-minute break or so.